Hi everyone, and welcome to our video lecture, Correlational Analysis. So for today, we're going to be talking about the types of variables that you might have for your analysis, types of correlational analyses based off of the types of variables that you have, and then examples of each. The second video lecture that is not here will be examples of how to do all of these in Excel. But the first step that you need to do if you're performing your own correlational analysis is classifying your variables. So variables measure a variety of different concepts, things like gender, age, democracy, prejudice against other groups, trust in other people, trust in governments, trust in other countries, all kinds of things. And we need to classify these variables as being one of three types: categorical, ordinal, and continuous. You need to classify them first before you run any analyses because it will change what analysis you can run. And this is true of more basic analyses, and this is also true of more advanced analyses. So you really need to make sure that you have categorized your variable correctly. For instance, it doesn't make sense to find the mean of a racial category, right? Like that, it doesn't make sense if 20% is African American, 30% is white, 16% is Latino, for you to find the mean there. That is not possible. The other thing is that you couldn't take age, which is a continuous variable, and use it as a categorical variable, right? Like if you had age ranging from 1 to 100, and then that was 100 different categories in your data set. Like that's a terrible idea, okay? So I'm going to get into a little bit more about each of these variables and these types, okay? So the first one is categorical or nominal variables. We refer to those sort of interchangeably. So these are the kinds of variables for which cases have values that are either different or the same as the values for other cases, but there is no ranking. There is no ranking to them. So there are no universally holding ranking distinctions. So for instance, you can see on the right, this is a map of regions. These are census regions in the United States: Northwest, Southwest, Central, South, Southeast, Midwest, Mid-Atlantic, Northeast. You cannot rank these, right? It's not like Central comes before South and then comes Midwest and then Southeast and then Southwest. There's no ranking to them. There are no bronze, silver, and gold medals here. They are nominal, right? There is no ranking to them. Another example is religious identification: Catholic, Protestant, Muslim, other, or none. Again, there is no ranking involved here, right? There is, again, no first, second, third. Muslim does not come before Protestant, and Protestant does not come before Muslim. There is no ranking, okay? So I think you get a general idea of what this one is. And it makes a little more sense in contrast to nominal or ordinal variables, These are variables that have categories, ordered categories, I should be clear, that can be ranked. These variables do not have equal unit differences, and you might be wondering what that means. So a good example first is these sort of subjective questions, particularly about like Likert scales. Would you say that you and your family living here are better off or worse off than you were a year ago? Much better, somewhat better, same, somewhat worse, or much worse. Here, they clearly have order to them, right? Much better is higher than somewhat better, and somewhat better is higher than same, and same is higher than somewhat worse, and somewhat worse is higher than much worse. But you're probably wondering what these equal unit differences mean. What really is the difference between somewhat better and much better? Or what's the difference between same and somewhat better? They are likely not equal differences between those categories. This is a little bit abstract, I know. Let me take an example from the Olympiads. So let's say that our gold medalist here one with a 50-second sprint, for instance. I don't know. This is, again, just me making up sports. Then the silver medalist placed at 54 seconds. And then the bronze medalist placed with 60. So the difference between 50 seconds and 54 seconds is 4 seconds, right? But then the difference between the silver medalist and the bronze medalist was 6 seconds. So they do not have equal unit differences between them. Does that make sense? The difference between gold and silver was 4 seconds, and the difference between silver and bronze was 6 seconds. So that's the idea here. They're still ordered in that gold was on top, silver was second, and then bronze was third. But the differences, those second differences in their wins, are not the same. And the same applies here, particularly for Likert scales. The unit differences between these are not necessarily the same. They might differ from person to person, and even the difference within the categories might be somewhat unique as well. The final one is continuous variables. So these are ordered categories that can be ranked, and they have equal unit differences between the categories. So for instance, if I have 2 children, which I do, the difference between 1 and 2 is the same as the difference between 0 and 1, right? If you have 6 children, as we see right here, the difference between 2 and 3 children is the same as the difference between 4 and 5, right? And the categories do increase in an ordered way. 1, 2, 3, 4, 5, 6, right? Going from 4 to 5 is the same as going from 2 to 3. You increase by 1 child. That's the idea there. The other example, which is really common, is age in years. So as long as it's listed as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, these are also considered continuous variables, and the unit differences, again, equal across the whole spectrum of values. So the difference between being 10 and 11 years old is 1 year, and the difference between being 22 and 23 is also 1 year. They're the exact same wherever you are on the spectrum. Okay, so this is just what a continuous variable is. Now, what should you use? So once you've classified your variables to whether they're nominal, ordinal, continuous, you need to choose which correlational analysis tool you're going to use for your own analyses. So if your independent variable is ordinal or categorical, and your dependent variable is ordinal or categorical, then you are going to want to use a tabular analysis. If your independent variable is ordinal or categorical, and your dependent variable is continuous, then you will use a bar chart. If your independent variable is continuous and your dependent variable is ordinal, you would again use a bar chart. And then finally, if your independent variable and dependent variable are both continuous, you would use a scatter plot. So let me show you examples of each of these. For tabular analyses, there are 3 steps that you're going to need to follow. The first is that you need to figure out what the variables are that define the rows and columns first. And preferably, you would have your rows as your dependent variable and your columns as your independent variables. If the second step is that you need to figure out what the individual cell values represent. So sometimes they will be the absolute number of cases that fall into each. Other times they might be proportions or even percentages. So maybe they range from 0 to 1, which is like 0 to 100%, or maybe they range from 0 to 100%, something like that. And then finally, you're going to figure out what, if you see any general patterns in your table. So let me show you an example to just give you an idea. So here, let's first make sure that our independent variable, here the theory is something like if you belong in a union household, you'll be more likely to vote for the Democratic candidate because there's a small association between union membership and the Democratic Party. So here our independent variable is the union household, right? Right here we can see from a union household in this first column and not from a union household in the second column. And then we can see vote choice in these right here, McCain, Obama, and that's our dependent variable. So the next step is to figure out what these values mean, okay? So here, this means that so down here, this is 100% of people from a union household, 47% of people from a union household voted for McCain, and 53-ish% voted for Obama. These are clearly percentages, right? These are clearly percentages. So this gives you an idea of what we are working with. And it even has a really nice note here. Cell entries are column percentages, okay? The next step we would see is if there are any general patterns. So from a union household, they are tending to vote a little bit more for Obama by about 5 percentage points compared to McCain in the 2008 election. Not from a union household, about 66% of people are voting for Obama and 33% are voting for McCain. This just sort of tells us that yes, there is a slight preference from a union household to vote for Obama, but it's actually quite high anyways. Like if you look at the average, it's about 55%. So it's not necessarily clear here that being from a union household really contributes that much to vote choice, right? Okay, so here our next example is bar graphs. Now you would want to use these when your dependent variable is continuous and your independent variable is categorical or ordinal. So an example that we have right here is, does the religiosity of a state correlate with how many people voted for Obama in 2012? So this is the percent of people who supported Obama in that state. And this is data from somewhere else. Like our dependent variable is here and our independent variable is here. But our independent variable is whether the state is highly religious, which is up here, sort of middle, moderately religious, or non-religious, low, right here. And as we can see, states that had lower levels of religiosity were more likely to go for Obama, right? He had a higher vote share. And then it drops down a little bit for moderately religious. And then those states that had really high levels of religiosity were less likely to support Obama in 2012, right? They had lower vote shares for him. Okay, so this is again an example of what this would look like. Your independent variable here is the categories of religiosity along the x-axis, and your dependent variable is the percent vote for Obama along the y-axis. Now, the final one is scatter plots, and you want to use these when you have two continuous variables. So again, just like algebra class, you want to make sure that your dependent variable is on this vertical y-axis and that your independent variable is on this horizontal x-axis. So here we're looking at the example of economic voting. So this is just, if you remember, the idea that economies shape election outcomes. And so here our independent variable is the percent change in real GDP per capita. That's our economy. And then our dependent variable is the incumbent party vote share. And as you can see, there is a pretty strong positive relationship going in this direction. It's not a neat, clean line, but we do see that as real GDP per capita increases, we also see the incumbent party vote percentage increase as well. In other words, people are rewarding the incumbent party in power when the economy is doing well. Now, we covered just now types of variables, types of correlational analyses, and then examples of each. But I'd like us to next head into Excel. I'm going to stop this video, and there's a second video that you should hop on to. And it will show you how to do these bar graphs and these scatter plots and these tabular analyses in Excel. Okay, we'll see you over there.